A long time ago, in a galaxy far, far away, 9 students from the University of Reading take off for Iceland on Saturday the 17th of September 2022. Volcanoes, glaciers, waterfalls and fumaroles will be encountered as they attempt to understand Iceland's geographical wonders. This video is a lasting message of their expedition. So this is an example of a real-life glacier or ice cave here in Poland, and it perfectly replicates what an ice cave would be in real life, to the detail where it even shows on this real ice here some ash layer deposits. This can be used to date volcanic eruption.
Iceland has a mixture of transform and divergent boundaries. These cause earthquakes to occur. Also, earthquakes can result from effects of volcanic eruption.
Glacier growth is controlled by the measurement of accumulation and ablation. The balance between this shows the steady state of glacier, whether it's increasing or decreasing. This can be increased by either dirty or clean ice. Okay, so this is a section of the mid-ocean ridge. As you can see here, we're currently on the North American plate. Over there in the background is the Eurasian plate. It's formed by the mid-ocean ridge. This forms where, along the North Atlantic, in the mid-Atlantic ridge, the two plates are spreading apart through upwelling. That causes the ridge push to push the plates apart. Iceland's also here because it's part of a hotspot where the land moves over the stationary hotspot, which provides mid-ocean ridge on land, as we see here today. Vesicles, little holes which form by gas bubbles extruding from the melt, and these are shown within the rock.
You can see the different layers of lava in the rock. Each layer is a different lava flow which can be dated. The layers at the bottom are the oldest. The thickness of the layer shows how much lava was produced at that time. Part of the ridge over there, which was towards the end, was roughly 7.5 metres across, and this is about 3.5 times the size of that.
Walking through the ridge, we observed a difference in the lichen coverage on either side of the ridge. On the right hand side, the face had a dense coverage of lichen, whereas on the left hand side, the lichen coverage was sparse. This could indicate that the right face is much older and therefore has accumulated a larger lichen coverage over time.
This is the Stropper geyser. This occurs because water deep within the crust is heated by magma. Once the pressure builds up, it eventually erupts. Geysers tend to consist of one hole at the top and multiple tubes of water feeding into it. The longer the tubes, the higher the pressure, and which decreases the boiling point. This then, in turn, lengthens the eruption timescale. Similarly, a larger heat flux can lead to shorter eruption periods as the water reaches boiling point fast.
So here we're at the top of the waterfall Goldbox. It has a huge waterfall spreading up down and down rapids here as well. It's fed by the glacier river, the river Havita. It's not a glacier that was flooded originally and it's been flying for many years. In terms of business safety, we've got some barriers here. There's not a lot, to be honest. Probably wouldn't pass in the UK.
We got to the Solheimjökull glacier, collected our equipment and climbed up onto the glacier. On the way up, the ice was covered in black ash, mostly from the 1918 Katla eruption. These have a peak formation that are constantly changing due to different areas being insulated by the ash. Moving further up the glacier, we could see the crevasses on the floor that move in a top to bottom direction due to the brittle ice on top expanding to fill the widening valley as it moves down from the ice cap. Once we got to the top, the hole had already been drilled, and so we measured the ablation wire left on top of the glacier to be 6.66 metres. This is used to see how much the glacier height is changing. In an average year, roughly 11 metres is lost, with 2/3 of it lost in summer. The worst days for melting is when it's warm and rainy, as water causes the glacier to melt the quickest. Satellite images can be used to see how much the glacier is retreating. In 2010, there was no lagoon here. It is normal for the ice to melt, but not at this rate. We also then got to hang over a crevasse.
Okay, we're here at Reki Adalur and we're doing some measurements of the metamorphic fumaroles and some of the hot springs. We're recording things like temperature, pH, electronic conductivity and dissolved oxygen.
So we're using the probe to calculate some of these measurements.
Parameters.
So you have to stick the end into the water.
lunch we went to Overk, the only geothermal brewery and pizzeria in Iceland.
It is very high maintenance and not always reliable, as the boreholes can get clogged. On these days, no steam is produced, so brewing cannot happen. It could potentially be expanded into other places, but would take lots of work to set up.
700 megawatts of energy is produced here. 43% of that is used for heating and 40% is used for electricity generation. The rest is used for other sources.
Okay, we're here in Sultan. It's very different to the first site where we did the hydraulic measurements. It's part of the new, or near to the new volcanic eruption site, and the deep groundwater heated by the magma is bringing up hydrogen sulfide. That's why you can smell and really see it. And because of this, the pH is much lower, sort of results of 1.2, so it's very acidic. And this is one of the problems with geothermal energy that wasn't mentioned, is the issue of the poisonous gas, and we're slowly poisoning ourselves now.
In this area, the absolute oxygen level is measuring at 19.5%. The normal is 24%. On day 5, we became a man down because Bonnie got COVID.
Product of the lava field from the 1972 eruption. As you can see, it's completely destroyed this building here. It's been reinforced by steel as well. The way it forms a blocky structure is it's more akin to a slow avalanche. When the lava's moving through, the top cools and it folds over.
We're at the top of Eldfell after climbing the whole way up. As we've come up the volcano, we've been measuring lichen sizes, and we found as we've got to the top there isn't any lichen to be found, which means the growing conditions must be unsuitable. We also measured ground temperature, and up here at the top it's 24 degrees, whereas down at the bottom the ground temperature is around 11. Eldheimer Museum provided background to the 1972 eruption. It is based around a destroyed home which has been preserved exactly how it was left after the eruption. Over 400 homes were destroyed similar to this. Also demonstrated was the project to use the steaming lava as a geothermal energy source, which in 1978 was used to heat 90% of homes in the island.
1973 fire fountain eruption produced 300 million cubic yards of magma and 26 million yards of tephra, adding around 1 square mile to Hemi, increasing the island size by 20%. The entire island population was evacuated, apart from 200 volunteers who stayed behind to spray 8 million cubic yards of water onto the lava to stop it blocking the port. This was the first time active management of lava fields.
So we're here at the graveyard where we are calibrating the lichen. So on the gravestones we measure the lichen to which so you can match up the date with on the gravestone. So this ash column shows the height of the ash outside of the cemetery here. So it measures 180 centimetres. Nobody died in the eruption in 1973, but 400 homes and businesses were destroyed.
Okay, we're here at the Lanatos waterfall. This is all coming from the Lanatal glacier. Waterfall is flowing over these lava flows.
Here at the waterfall, the lichen are a lot bigger than the other sites we have seen, because this shows that the lava that's flown across is a lot older.
Finally, we went to the cave, which formed around 900 AD from a fissure-led lava flow. The cave formed as flowing lava accumulates in one large river of lava. The outside of the lava starts to cool, whilst the molten centre continues to flow, eventually capping at the end. The cave contains many geological features such as lava, lava candles, and a lava shit, which are stalagmites. Also present was a chocolate wall, which represents a slow cooling via magmatic differentiation.
Yeah.
Okay, so we're here at the top of the hill here. We can see the lava flow in the background. We can see it's flowed all the way down from the crater up here from the fissure eruption. So this will be the lava flow from the 2021 and 2022 lava flow down, and we can see the gas is dissolving off of there.
Down here and all along here there are cracks in the surface, and this is where the lava has run over and then cooled, and when it cools the rock gets smaller and so it cracks on the surface. You can also see there's a lot of rippling effects along the floor. Over there is where the rock has cooled and it's blistered from where the gas has come up and made bubbles. So on the floor here you can see a couple of cracks that are surrounded in white, and this is where sulphur has been released when it was cooling down. We also got the opportunity to go to the Blue Lagoon.
The Iceland field class provides us a fantastic opportunity to apply the knowledge we have obtained in a practical environment, as Iceland continues its dynamic nature of constantly morphing its landscape. Until next time, goodbye.
Go.
Okay.
Go. Go. Go.
Go. Go. We're here at the middle of the... Start again. Ready?
Am I going?
Yep.
And then they have buttons that show each of the different results. So for this river, Okwa is a 1,170 meter high. They will also cause the weight of the land to rise, which causes, what is it called? Isothermic? I don't know. Carry a large amount of
Ice breaks into a major crevices and earthquakes can also occur. Wait, start again. What am I saying?
Go.
Oh, one thing though, you're covering the mark.
Nice one, Josh.